Combining like terms. Terms are the pieces of algebraic expressions. So, if you have 8 minus 3z minus x, the terms are the different pieces of that expression. And we determine where a piece starts and begins by finding plus or minus signs. So we have a minus sign right here and a minus sign right here. So these are the three terms. 8 is a term, 3z is a term, and x is a term. Take a look at the second one. 34 plus 4v minus 39z. This is an algebraic expression, and we want to find the terms. Terms are the pieces of that expression. So this one has a plus sign and a minus sign. 34 is a term, 4v is a term, 39z is a term. Now when we look at those pieces, we can group them according to like terms and unlike terms. Like terms are those that have the same exact variables with the exact same exponents. For example, like terms would be 4 and 8. They don't have any variables, so they can go together. Another example would be 4x and 8x. Those both have the exact same variables. Another example would be 5xy and 11xy. You could also do 7x squared and 2x squared. They both have the exact same variables and their exponents are exactly the same. Those are all examples of like terms. Unlike terms would be ones that have different variables or different powers. So 4x and 8, they are not like terms because they have different variables. 4x has x and 8 has nothing. This one, 5y and 6z, are not like terms. The variables are different. 8x and 8x squared are unlike because the variables might be the same, but their exponents are different. Simplify the expression 3x plus 9 plus 2x minus 5. There's a couple ways of doing this. We can use the commutative property to rewrite this expression as 3x plus 2x plus 9 minus 5. Now we can use the distributive property to take this x away from the 3 and the 2. So that would be x times 3 plus 2 plus 9 minus 5. Now we can use our order of operations. Parentheses go first, and that's going to be 5. So there's 5 x's, and 9 minus 5 is 4, so plus 4. The other way of thinking about this is thinking about it in terms of like terms. We have 3x plus 9 plus 2x minus 5. 3x goes with the 2x. They have the exact same variables. So we have 3x's plus 2x's, that makes 5x's. We then have the 9 and the minus 5. They have no variable, so those are like terms, and we put those together. 9 minus 5 is a positive 4. Simplify the expression y plus y plus y. Well, we could use the distributive property and say that we've got 1y plus 1y plus 1y, and take that y out of all of them. So y times 1 plus 1 plus 1, and 1 plus 1 plus 1 is 3 y's. Or you could do it the easy way and recognize that we have one y plus another y plus another y. That's a total of 3 y's. Simplify the following expression. Now, someone might say, well, geez, I don't know what I'm doing. I'm just going to put this all together, and I'm going to say 3 plus 8 plus 4. That's 7 plus 8 is 15, and I'll just put those x's together and have 15x squared. Well, that's not correct. That is not the right way to do this. You can only put together like terms. So, does the x squared have anything that's the same as it? No. So it's going to be just x squared plus, now look at the 3x. Does it have any other terms that can go with it? Yes, the 8x. They both have the same variable. So I have 3x's and 8x's. That makes 11x's. Finally, we have the 4. It has no variables. We can't put it with anything. So this is the simplified version of this expression. Simplify this expression. 7z plus 2 times the quantity z minus 5y. Well, we have 2 times the quantity here. Well, we're going to need to use our distributive property, and that means we multiply 2 times all of the terms on the inside. So it's going to end up looking like 7z plus 2z's minus, don't forget 2 times the second one, 2 times 5 is 10y. The question is there any like terms that we can put together? Is there anything that goes with the 7z? Yes, it can go together with the 2z. They have both the same exact variable. So 7z's and 2z's makes 9z's minus 10y, because that one can't go with it. It has a different variable. This is the simplified version. We can't go any further because we don't know what z is and we don't know what y is.